Thank you so much for having me today, and this is really exciting for me to be part of this group. Just a couple of words about who I am. As Vipin said, I represent Exactpro, and we are a firm who is focused on software testing for financial sector. As a business development manager, I'm responsible for partnerships and events here in the US. And I'm also a part of the Exactpro research team, which means that I take part in our research activities, be it research paper submissions, or maybe speaking at the conferences, or maybe making the overviews of for some internal use. And this is exactly the reason that why I am also a part of this group, because the discussions that you give here are really high quality, and they are really important for us because they give help us to understand what's going on in the capital markets sector related to the DLT domain. So let me share my screen in just a couple of seconds, and I will start with the presentation. Okay, can you hear, can you see it okay?
Yes.
Yes. Yes.
Okay. And here we go. All right. Just maybe a couple of words about the company itself. So Exactpro provides quality assurance services for exchanges, clearinghouses, investment banks, brokers, and some other financial institutions, performing both functional and non-functional testing. And we've been a part of the London Stock Exchange Group between 2015 and 2018. In January 2018, Exactpro completed a management buyout from LSEG. We are headquartered in London. We also have operations in the US, in Georgia, the country, and we have several offices in Eastern Europe. Exactpro currently employs almost 600 specialists, and as I mentioned, our focus is mainly in financial market infrastructures, and our current clients are quite diverse in terms of their geography. We have clients in over 20 locations on all 6 continents, and from the beginning, the main focus was on traditional technology. So our first engagements here were in the trading and post-trade areas. And then maybe a couple of years ago, we got interested in the distributed ledger technology, and we tried ourselves in a couple of POC projects. But at that time, most of DLT was that early day attempts to build an application and to prove that it actually works. The whole idea of testing is exactly the opposite, to stress this system to its limits, to expose it to some stress and to expose its weakest points, and to see what happens in the worst case scenario. So back then, the industry was not exactly ready for really extensive testing, but surprisingly, quite quickly, it came up with the solutions that needed real testing. First, it happened in the area of DLT per se, and then we were also contacted by some digital exchanges for whom testing turned out to be extremely important, given they need to be established as part of the capital market communities, and most of them are still struggling with the regulatory challenges. And just for you to understand the context of our work, I'd like to describe our general approach to testing of traditional technology, what is usually involved here from a software testing perspective. As everyone here knows, I think the underlying technology into the financial sector is extremely complex. First, the complexity is caused by the structure of a typical platform within a systemically important infrastructure. The most vivid case study for testing would be probably a post-trade system, which can have about like 80 inward and outward connections, dozens of components, sophisticated system dependencies like upstream and downstream. Such systems also have complex participant structures. So they work with lots of asset classes, and they are accessed via diverse APIs and protocols. And the second aspect of this complexity is the life cycle of such a system, because the system's daily activities involves for post-trade, for example, it's trade uploads, different calculations, computation, margin runs, settlement sessions, and so on and so forth. And all of those activities are performed every day. They happen in a predefined order, and they happen at predefined times. And they depend on each other. And actually, what does it mean for us in terms of software testing? That means that to test such a system properly, we will need to test all these repeatedly happening processes and to test them with all the multitude of parameters. So in other words, this leads to hundreds of millions of tests, which is apparently a problem that can be approached only with the automation. So as you can see, so it's already enough complexity to deal with from the software testing perspective, even before DLT is brought into the picture. So for that, even for pre-DLT, I mean technology, we used to address this complexity with our test automation tools. And here on these slides, there are just two examples of those. One of the tools is aimed for testing the complex scenarios and business life cycles, and it supports concurrent work with multiple gateways, with diverse protocols and APIs. And on top of this tool, there was an enhancement allowing testing at the confluence of functional and non-functional testing. So that was the pre-DLT era. And then we noticed that financial institutions started gradually adopting DLT, which of course required a significant transformation and replacement of the core parts of the platforms. So to address those changes, we started to think about what the test approach for new transport platforms should be like. And we decided to accommodate the test approach, and we needed to understand the new challenges, the challenges introduced by the DLT. And at the very beginning, it was absolutely clear that all the challenges around the complexity are in place. So the traditional challenges didn't go away, and DLT did not eliminate them, of course. In fact, they became even more pronounced now because of the hybrid nature of the new platforms. So compared to traditional systems, DLT platforms pose additional challenges in terms of quality assurance, and these stem from the necessity to verify the interoperability of nodes in the network, because there are a large number of connection permutations between them, and you need to understand the differences between varying permissioning logic. There are also challenges stemming from the non-functional requirements to DLT platforms. They have to be really high performing, having considerable transaction throughput, and another requirement here is very high availability, especially in those components which are aimed to ensure the correctness around the logic of the ledger states and their correct and smart contracts and the correct propagation of the changes across the network. Maybe another weak point here is, of course, continuous upgrades, where there is a risk that something will go wrong. And again, the error could be propagated to the entire network. Apparently, to address those challenges, we need a two-pronged approach with both functional and non-functional testing, be it testing of the network plumbing itself or the distributed apps. So we found here that there are a number of test tools properties that we needed for testing DLT. And as for the platform itself, our case study that you can see on this slide covers the experience with the R3 recorder technology. From the functional point of view, the existing testing tools needed to be improved with the following capabilities. So as you can see on the diagram, it represents main DLT system components. It is a network of nodes, and our tool was used for extensive end-to-end test automation of this scenario. And it was adapted so that we could simulate main node functions on the Hyperledger. In order to send a transaction with certain parameters, we predefined them in the automated script, and such a script we internally call a matrix, but actually it is a file in a CSV format. During testing, a whole set of matrices is run concurrently through multiple connections, and for different connections, we can trigger here the interaction between the nodes, and we can check the results in volts. And some of the other enhancements are also listed on the slide. So this is around nodes deployment, ability of word apps deployment, nodes administration, and so on and so forth. So this was a case study for testing the network itself and from the functional point of view. And the next slide demonstrates the approach to the very same coordinate network, but from the non-functional point of view. So as you, again, you may know, non-functional testing of any platform is extremely complex, and it requires robust configuration and may even involve some preliminary development activities around it. So to run automated non-functional tests, it's required to monitor various metrics of the platform under test and its hardware usage. It is also very important to have the option to start, to stop, to adjust load injection or some other actions based on the current system state. So the Exactpro automation framework allows the initiation of flows across a large-scale network of nodes, and we can do it against a remote network. We use open source tools here to gather metrics, to visualize the results, and we are now able to cover various non-functional testing types. As you can see here in the slide, it's load and stress testing, failover testing, soak testing, and the measurement of latency and performance. The last two case studies are more examples of functional testing of distributed apps, as in contrast to testing the network plumbing itself. So in this case, our test tool was adapted to simulation of nodes for the trade reconciliation and position update business flow. As you can see, it's for two parties and a CCP. For this scenario, of course, this is a much simpler case, and in this example, testing was orchestrated using just Exactpro test tools. Some of the framework components emulated the nodes. Some of them triggered some actions through RPC calls, and some performed checks on the ledger. And another case study is again around the business layer, and it is the one with the digital asset modeling language, DML. And here we used digital assets swaps lifecycle module application, which was based on the ISDA CDM model. In this case, the simulation that we did was performed in one of the parties node, as well as in the market data provider node. Plus, testing framework emulated time shifts to facilitate the checks which were associated with a particular lifecycle events in a swap. So this is basically it. I outlined the pains that we had before with testing traditional platforms within large-scale market infrastructures, and shared some examples of how one can adjust their testing to fit the new needs which are emerging with DLT. So thank you so much.
Elena, congratulations. It's a very comprehensive look at the complex landscape. Maybe we went through it a little fast, but I'm sure people have questions, okay. Especially since I noticed Jim on the call. He's already asked questions on the Zoom. It says, did you use JMeter for loads? Did you test CI/CD and change management? Mm-hmm. How do you define bad test data cases? Anyway, you can read just like I can, obviously, but I'm just drawing your attention to the questions on the chat.
Right now, I'm looking at this at my presentation, so maybe I'm stopping.
No, it's okay. You can. I can read it out to you. We can answer.
I'm looking at it right now. So regarding the first question about the JMeter, we use an internal tool for that. So to generate the load, we use our own load injector, which in some way is similar to JMeter, but it is more adjusted to our needs, to our specific knowledge domain area. So it's more focused on the trading software. So for non-functional testing, we mainly use this one. And regarding the CI/CD, yes, we use open source tools here, and of course we use it extensively in our experience. So. How do you define bad data test cases? Our overall approach is an extensive end-to-end testing. So that means that we look at everything. So that's why I started my presentation with this maybe not really interesting for you overview of the complexities of a typical platform. So as you can see in our testing, so many things are involved. So we look at the data, we look at data permutations, we look at how data is transmitted from one point to another, because through different protocols and APIs, the data can be changed, or for example, if we receive some data from market data feed, we receive it in one format, and if it is received by some custom application or component in the platform, and then it's transmitted to some downstream system. The data structure can be changed a little bit, so we test for everything, for all the permutation. I hope I answered the questions, because I think that here you can have several understanding of that, right? But data test cases. So if it doesn't answer your question, so you can always contact me, and I will try to offer you another reply here. So pre and post assertion in your test framework. I'm not sure how to answer this.
Certain languages. So some languages provide, I'll call it capability for pre and post assertions, much like a JUnit kind of a thing, right? So you can say that the entering state is X, the exiting state is Y, and you can assert that those things are, and then you look for what I call the transformation in the middle, if that makes sense.
Yes, it does. And I would say that we do not focus a lot on the formal verification here. So it's more of the overall business functioning. And we specialize more on the back testing, like for APIs and protocols interaction. So we approach testing from more black box perspective.
Thank you.
The next one is about the whether you use some kind of identity OpenID Connect authentication.
I'm afraid I'm not familiar with this, so I'm not really
basically, what kind of identity model do you use in testing, or you do not? You just go with one. In other words, like in some frameworks, like Caliper, for example, you have a way to spin up hundreds of clients with multiple identities interacting in complex ways, because that will simulate the real life. Here, of course, Jim is referring to a specific identity framework called OpenID Connect. But you know, you can use any various different ones depending on the identity model inside the framework.
Yeah, I understand. It's just I'm not so deeply involved in testing, so that I cannot answer this one, but I can get back with the answer like later, sometime later. I think we have a dedicated page on Hyperledger portal, right? So if it is...
Yeah, we do, and questions can be asked and answered there.
Yeah, this is the one I just have to go to my team and just ask.
Yeah. I mean, you know, these are. I mean, testing is a vast sort of landscape, and I see that Money has his hand up, so obviously he's got some question.
Hi, Elena. Thanks for a great presentation. Can you elaborate more on the digital asset and the CDM testing with respect to IRS and CDS, considering the fact that CDM is, continuing to make a lot of changes? How do you do this testing? How or when did you do the testing? If you could give me more, elaborate a bit more on the CDM testing itself, would be great.
So first of all, I wouldn't call that the testing of CDM. So this wasn't a testing of the underlying model, because as you know, CDM is a framework, like it is a description of business scenarios, right? Which was used by the demo SDK. And we focused here more on the application level. So we simulated the business flow. We tested the the business logic, how everything is working on the level of this very application. So it was a proof of concept project, so it wasn't like a production case. And yes, and maybe some more interesting detail on CDM. We were not only testing this, we actually participated in hackathon, and we even developed some application, but on Corda framework using CDM. So if you heard about this dairy hack,
yeah. We participated as well.
Yeah, we were participants in Singapore, and we took the prize for best CDM adoption or something like that. But it was
Oh, that's great. Yeah,
trying ourselves here. But from the development point of view, it wasn't from active.
Thank you.
Thank you.
Anybody else has questions for Elena?
No, but I did want to say that was an excellent presentation. Obviously, you put more than a couple months of effort into building out this extensive test environment, which is really robust. And I can agree, having been on the other side of the fence at Fidelity, having responsibility for those systems, that a much higher level of testing is needed. So the fact that, in a sense, your company provides that, that's a big, big value service. And there's very few companies, honestly, that have a high focus on what I call bad data, which is more important than big data in resolving things. And I can almost separate them. And I say all of the broker dealers that you're familiar with don't have a super high threshold, or I'll call it a quality pain point. Whereas when I flipped it around to the JP Morgan data services, those guys were way up there on the food chain in terms of the priority for accurate data. So there are some differences there, and you kind of have to fill the gap with the client where they don't have that same standard, I'm sure.
Okay, thank you. Thank you so much.
Thanks.
Anybody else?
Yeah, I have a question related to the most common errors, right, or mistakes as you work with many clients. If you were to maybe highlight some of the main issues that you encounter on the test design, or if you could share with us some of the most common occurrences.
But I think I'm not about speaking about the details here, but maybe the main pain point that we experience is connected with the underestimation of the complexity of the platform. So everybody is talking about digital transformation, about I don't know, AI and DLT and everything, and they think that those new technologies pose huge risk. But in fact, the most of the risk stems from the non-determinism of the current platforms, because they are really complex and no one really understands how they work. I mean, in depth. So there is no in-depth understanding of the exact workflow of what if we change this data and what will happen. Especially this makes sense in the face of the crisis that we can now see, because before we had lots of problems with stakeholders of the systems that we tested, because sometimes we came there and we tried to perform some tests, but they came back and said, oh, okay, guys, this scenario is really unrealistic, so why are you doing it at all? And especially this can be seen in non-functional testing, performance testing, because we test at insane levels of loads, and the clients think that we just want to break the system. Actually, this is true. We try to break the system because it is important to see the system's reaction. We have to be sure that it has certain failover capabilities. But the spike in the volatility showed that some scenarios which we were told were unrealistic, they proved to be realistic in current situation. So this is definitely was a mistake of some of our clients not to understand this. Well, what else? Yes, most of the problems that we uncover, they are not in some particular place of an application or in some particular component. So I cannot say that some components are innately prone to these errors, but it is rather at the confluence. It can be either at the confluence of like DLT to non-DLT connection. It can be at the confluence of functional and non-functional testing, because if we create just some load, we cannot see we can not see an error, we can like miss it, or vice versa. Doing functional testing, we can again miss it. But if we do like a smart simulation or smart model-based testing, which involves generation of lots of scenarios and loading the system under test with these scenarios, using this approach, we can find some errors. And again, one more thing I can think about is the errors which occur when we upgrade systems, when we upgrade some components of the nodes. So something that is related to systems. Yeah.
Okay, thank you so much for sharing. Yeah, it's really insightful.
Thanks.
Elena, can I ask you one more question? A major challenge for you, I assume you guys have it's not a project approach, but you probably have an ongoing relationship as the test environment for a given company, right? You're their testing service, correct? Normally, I would assume.
Say it again.
Well, what I'm trying to say is, a company doesn't hire your company to come in and say, just test temporarily. They're hiring your company, I assume, to do, I'll call it continuous testing over a long term.
We have different engagements.
Okay.
You're absolutely right that we do have multi-year service agreements, but
so
there are lots of cases.
If I look at your multi-year service agreements where you're considered the primary testing facility, for a company, how are you integrated into their change management system? Because every time they make a change, it would impact your testing. So how does that integration process work for you?
The answer is simple. Our testing framework is usually deployed into the client's framework. So it's in their network, it's on their premises, or it's in their cloud. So the testing tools are like part of this framework. They have internal access and so on and so forth. And I think it's a really small percentage of our testing that is performed on our own frameworks. So this is mainly on our infrastructures. Yeah.
Anyone else has any questions? If not, I have some.
Okay.
You mentioned, you brought up the question of black swans. Basically, nobody is aware of the extent of the stress scenario until it actually happens, which is the true definition of a black swan, because it is not within people's minds to think about these things. I myself, when I was running a mortgage-backed security system between 2008 and 2016, we created tests like pandemic. We did create tests like a nuclear attack in Times Square. We did create scenarios like California earthquake. All of this, of course, resulted in a model-based approach saying, the spreads would widen by this much amount. But the problem is, the spread widen, even those metrics are difficult to project because it's all based on somebody saying, okay, if there is a global pandemic, this is how much the spread will increase by. But it may be not like that at all. So to bring all this back into the picture, we, I had written something about chaos testing inside inside blockchain. I'm one because it is now available on Medium, but we had started thinking about this because the whole practice of chaos engineering is based on the premise that nobody can have the entire system in their head. I mean, it's impossible for this complex system, which the point that you just made just a few minutes ago. I think this is definitely the case with complex systems. So chaos engineering theory basically tries to inject faults in a random and chaotic fashion.
Yeah, we are great adepts of this theory.
What's that?
Yes, we really are into the theory, and we know about this, and we use some of its principles in our testing. And speaking of the black swans, we prefer not to think about what happened as a black swan because apparently it is more of a white swan because it was predicted long ago, and what we now observe in financial market infrastructures, how they are responding to the crisis, it was actually tested because again, we always we do not hope for the best or something. So some firms have certain thresholds. For example, there are rules within the company to test something at, for example, double of historical maximum. So this is not our case. This is not how we work. We do not have such thresholds. So we do not have any presuppositions what is the bad scenario. We just test for the very, very worst case scenario. So we kill the nodes, we try to kill the system components, so we just go for a kill, and then we just see what happens, how the system reacts, what's happening, what is its behavior, and based on that, so our priority is the ultimate quality of the system, and our ideology here is that we have to focus on the white swan events that we have. So it's enough of those. And we have to be always prepared for the worst.
Well, because you don't think that these are black swans, they're all white swans.
Yep, exactly. For our testing, so we always anticipate those the highest volatility, the highest loads, the highest outages of the distributed systems. So this is something that we test.
Well, that means you live in Australia, because black swans were found in Australia, and when the English landed there, they saw that these black swans. Obviously, they were not black swan. They were not anything special for the people who lived there, and we're used to seeing them every day. So in that sense, yeah. Anyway, so it's all very, testing is a very comprehensive practice, and it's a very specialist practice. And it has to be continuous, like Jim was saying, obviously, whenever there's change, either in the software or in the infrastructure, the deployment itself, like, you change the number of nodes, you change which, if you're going to multi-cloud or if you're doing any other kind of things, those are all changes that affect the software. One of the other questions I have is your practice, your slides, are they available or are they not?
Yes, I can share them with you. Or I think I can publish them myself, right?
Yeah, you can go to the agenda website or meeting website, which I've set up. It is a meeting minutes for this call, and you can just download your slides over there, and then
maybe
link them. If you have difficulty doing this, just send them to me. I mean, either way, it's fine.
Okay, maybe you can.
Okay, I'm going to put the link in again because I had it earlier, because I want people to help me crowdsource not just the meeting minutes, but reactions, their own presence in the, so I have the agenda link in the chat if you want to go there. But we can have exchange later, and then we can do this there.
Okay, and we also have this case study that I partially ran through on our website, so it is open for download, so you can go ahead and do this. But of course, I will share some slides as well.
That's great, because I think it's important that when we come to deployment, we should be thinking about these, testing even before we get it out into the open. Now, any of these pieces of software or anything there that is available on a demo basis or on a open source basis from your site, or is it all paid stuff?
We do not charge for our tools. We have actually some of our tools in open source, so it's on our GitHub web page. We also have several videos on the topic. So one of them is here on this very page, which I referred to when I spoke about the case study. And maybe there is, and there is also a video with covering this case study. This is a video I recorded from home, so during the pandemic already. So if you want to see me again, go ahead to our YouTube channel and explore some videos there. So.
Yeah. I mean, it's more the material that is very compelling, and you're a very sympathetic presenter, so that is a very good thing. Anybody else has any more questions on this topic?
No, but it was an awesome presentation, Elena. Thank you so much.
Yeah, if I may, one additional question. Elena, I don't know if you heard about the token taxonomy and the joint initiative that many companies, they are gathering together to define standards agnostic to the platform. And when you think about testing, I know that you may go from a higher level of abstraction, right? until maybe to the very fine grain, a detailed unit tests. So in that sense, talking about token standards, have Exactpro engaged in any conversations related to a more like a business level, if you will, and how to design comprehensive tests for different token standards, whether they are smart contracts, right? Specifically to blockchain, for instance.
Yeah, I'm sorry, I missed the name of the framework. Was it TTF?
Yeah, the token taxonomy framework. It's a joint initiative that they're trying to come up with token templates that would define behaviors and also properties. So whenever somebody wants to implement those templates, they could be reused and extended to their specific business needs.
I'm afraid that the only place that I heard about this framework is in this group, in this very group. So thank you so much for sharing this knowledge. And I'm afraid we haven't looked at it yet in terms of testing. Unfortunately.
Yeah, sure, no problem. Thank you.
Well, you know that we have implemented that e-teller, which is based on this framework, and we are adding more. We may add more security definitions on that framework. But recently, they have migrated to another group called IWA. We talked about it in this group before. So anyway, I think it is going to have the similar effect, let's say, as CDM on the contract side. So it is always good to incorporate some standard methods. I see that you have in your slides a reference to Swift ISO 2022 messages, probably. So these are all standards, but the problem with ISO 2022, for example, is it seems more like a union of existing messaging standards, and they are not cryptographically sealed or cryptographically integrated properly with the lineage and everything else like CDM is. So we have that, we are coming to the new age in terms of those messages. So I don't know how far this, I know that ISO 2022 is a recent standard and heavily used in ASX, where DAML was very active. But I wonder about the future of these kind of frameworks, which are not, which do not have this internal integrity. In fact, some of the most famous hacks against Swift came because of this lack of lineage or cross-reference, because the Bangladesh hack, all the other, system hacks that have been perpetrated against Swift have come because you can enter the message stream at different points, the weakest link, for example, and create messages that are not integral to the chain, to the the flow, and hence create problems. So I don't know whether Swift themselves have thought about this. That's another topic for another time, but still, I think the testing could incorporate these kind of things into the framework. What were you saying?
Yes, absolutely. Though, if it is more about the functional side, so if So we do not do the security testing per se, but from the business perspective. So I think this is a very good idea to incorporate this into the testing. And the ISO 22 is really, we can already see it incorporated in our business scenarios within our clients. So this is, of course, something that definitely has future.
Okay. Any other questions for Elena before we go to the next two items? Okay. Thank you, Elena. And we will be looking forward to getting a copy of your slides, and I will put the recording up, which shows you in your glory talking about all this stuff. It's very, very good because this is one of the topics that is often missed.
Okay, thank you for your time, for your attention. Thanks for having me.
No problem.